As with other products, electricity can be monitored for quality. High-quality electricity is consistent, reliable, and free of distortions, interruptions, voltage transients, and other anomalies that can interfere with the safe, efficient, and economical operation of equipment. To help ensure the quality of electrical sources, the standard EN 50160 has been developed. This standard, originally published in 1994, is designed to promote a common understanding and definition of core quality characteristics among electricity distributors. EN 50160 has been widely adopted in Europe and also has applicability in other parts of the world, including the Americas. In this video, we briefly review the purpose and scope of EN 50160. We'll also look at how you can use AEMC Instrument's Data View software in conjunction with your PowerPad III Power Quality Analyzer to monitor your electrical distribution system for compliance with EN 50160 specifications. To help understand the need for EN 50160, consider the nature of power sources. Simply put, a lot can happen to electricity on its way from the power station to the supply terminals. Although the electricity produced by the energy plant may be of high quality, factors such as lightning and other weather phenomena, various forms of electromagnetic pollution and disturbances, and other influences can introduce degradations such as supply interruptions and voltage dips. In addition, electrical equipment operated by you or by other customers on the network can introduce additional electrical disturbances such as harmonic distortion, voltage fluctuations, and so on. These and other factors can have a profound impact on the quality of the electricity being delivered at the supply terminal. Unfortunately, the nature of electricity can make it challenging to counter and eliminate these types of disturbances. However closely the energy producer may monitor quality at the generation facility, it is virtually impossible to completely accommodate all possible sources of electrical disturbances from the distribution network. On the network, the use of electricity is essentially simultaneous with its generation and distribution. This means that disturbances have an instantaneous impact on electrical quality, without allowing a time interval for the distributor to take potential corrective actions. Thus, it is often up to the consumers to monitor electrical quality to ensure the power source meets the requirements of their facilities and equipment. Low-quality power can result in a number of issues, including unexplained failures, intermittent malfunctions, and underperformance of equipment. EN 50160 has been developed to address this need for monitoring and measuring source power quality. EN 50160 defines a set of specifications and allowable tolerances for characteristics including frequency, slow voltage variations, rapid voltage changes, harmonic distortion, unbalance, and other conditions. These variables are set forth in the EN 50160 standard, which can be viewed and downloaded from a number of online sources. Note that in addition to these specifications, EN 50160 also defines a number of allowable exceptions and exclusions, in acknowledgement of the fact that current technology makes it infeasible to completely prevent all possible types of electrical disturbances from affecting the distribution network. Note also that EN 50160 is narrowly focused on the quality of the electricity produced, not how it is produced. For example, it does not cover environmental factors such as emissions. AEMC's DataView software now supports EN 50160 monitoring through the updated PowerPad III control panel. This program, which is provided free in North America, enables you to use your AEMC PowerPad III instrument to check your electrical distribution system for compliance with EN 50160 specifications. Supported instruments include the Model 8435, Model 8333, and Model 8336. To use this feature, ensure that the latest version of DataView with the PowerPad III control panel has been installed on your computer, and that your PowerPad III instrument is powered on and connected to the PC. The online help that comes with DataView explains how to do this. Start up the PowerPad III control panel by clicking its icon on your desktop. Ensure that your instrument is connected by looking for the green check mark next to its name in the navigation frame. If a red X appears instead, connect the instrument now by clicking Instrument on the menu bar and selecting the option Connect or Reconnect an Instrument. With the instrument connected, select Instrument and then click Configure EN50160. After a few moments, the Configure EN50160 dialog box appears. Note that you can also display this dialog by clicking the Configure EN50160 icon on the toolbar. The Configure EN50160 dialog consists of 5 tabs. General displays the distribution system type and other variables associated with the system under measurement. You can also name and schedule an EN50160 monitoring session. Slow variations sets parameters for identifying how much a measurement varies from its acceptable value defined by EN50160. Rapid voltage changes and interruptions configures the monitoring session for detecting rapid voltage changes and interruptions in the system under measurement. Dips and swells define settings for monitoring dips and swells, also known as overvoltage events. Transients sets conditions for capturing transients in the system. Complete the fields on these tabs to configure the EN50160 monitoring session, as explained in the Data View Online Help. To see the results of a completed monitoring session, download the session from the instrument by selecting Download Recorded Data from the Instrument menu. Or you can open a previously downloaded session by selecting File from the menu bar and clicking Open. Find and select the monitoring session via the Open dialog. The results of the session now appear under My Campaigns in the navigation frame. These results indicate whether or not the monitored system passed EN50160 specifications for slow variations, rapid voltage changes, long and short interruptions of the supply voltage dips, and supply voltage swells. You can use this information to identify potential problems and implement corrective actions, such as adding equipment to mitigate issues in electrical quality. This concludes our brief introduction to EN50160 monitoring. Be sure to check our YouTube channel for instructional videos on additional topics in electronics, including how to use the many instruments offered by AEMC.